Good afternoon, everyone. This is super loud. Anyways, I hope this is only disturbing for me. Good afternoon, everyone. My name is Philipp Langer. I work with EclipseSource, and I'm really happy to be here today to talk about building your custom UML-like tool, custom in the sense of domain-specific UML-like tool based on Papyrus. Before I go into the details of Papyrus, I really want to show you how we use usually Papyrus and when and where we apply it. And this is why I would like to go a little bit give you an overview of what we are doing usually, and then discuss when we decide to use Papyrus and how we actually use it. So at EclipseSource, one of the larger part of our project is dealing with building domain-specific modeling tools based on open source technologies in various different domains, so ranging from software and systems engineering domains over to normal information systems. And what all these different types of tools have in common, that we are building them based on the open source technologies that exist in the Eclipse modeling ecosystem. Since these are employed in different domains, they also, of course, look very differently in terms of that they use different sorts of editors in order to allow the domain experts to interact with those models, the underlying models. And they also implement in one way or another the methodology that these domain experts usually apply. And in our experience from introducing modeling tools into organizations, one of the most important success factors is that the modeling approach and the tool is introduced and customized to be as domain specific as possible. So we didn't make a lot of good experiences with taking an off-the-shelf tool and putting it into an organization and hope for the best, but really like investigating and analyzing how we can best help domain experts and support them in their usual methodologies instead of changing their methodologies. So building a domain-specific modeling tool is really about customizing an existing generic tool so that it directly reflects the specific needs of a particular domain and, of course, its domain users. And that, of course, requires us to take into account their roles, their backgrounds, their methodologies, processes, and so on. And it's easy to imagine that this will, of course, result in a different tool, whether you are catering for a software architect, a systems architect, or an electrical engineer, right? So they need some sort of different ways of describing their systems. Of course, one large and important aspect is the domain-specific modeling language, which is shown here. But it's important to realize that this is only one part for a successful domain-specific modeling tool, because the modeling language is just one single artifact. However, the domain engineer always will use and judge this domain-specific modeling language together with other components, such as, for instance, the domain editors with which the domain user can actually interact with those models, and just as important, different components that process these domain models in one way or another. Because usually modeling is not a purpose on its own, but you apply modeling in order to answer certain questions or to fill a certain goal. And that's why these components here on the right-hand side, like code generation, validation, simulation, and so on, they're really important because they actually produce the value for the domain engineer. So talking about UML-like, usually UML is associated with graphical modeling or diagrams. So when we now take this into the domain-specific graphical modeling area, we are dealing with diagrams that may look like this, right? So they use domain-specific shapes that make sense to a domain engineer in a certain context. They use edges, they have probably properties when you click on them where you can specify the details and all of that sort. And they should be, of course, also reflecting the domain concepts as closely as possible. Best way, for instance, is look at the PowerPoint presentations of those domain experts, because there you will find exactly how they usually, in a graphical way, express their domain concepts. And based on those PowerPoint slides or those shapes in those PowerPoint slides, you will likely find hints on how your graphical language should actually look like to be as close as possible to what they would like to have. So with this in mind, when we usually go to organizations and everyone is on board that we would like to create a domain-specific modeling language, usually this or some sort of this kind of discussion arises. And this discussion usually starts with analyzing your domain-specific modeling language that you would like to create, and then someone points out completely correctly that there is a part in this domain-specific modeling language that actually looks a lot like, let's say, UML activity diagrams or UML state machines, or choose whatever your favorite UML diagram type is. And that's, of course, that makes sense because UML is a generic modeling language. It has been built to cover the most important aspects of a system. So it's quite common that a domain-specific modeling language also reassembles one specific aspect of this generic way of expressing, for instance, activity flows and stuff like that. So someone points out that the domain-specific modeling language actually looks a lot like, in part, like UML. And then, of course, the counter argument is, yeah, but of course, in our domain-specific modeling language, there is a lot of concepts that are not reflected in UML. And this is, of course, correct because it's a domain-specific language, right? But at the same time, we also don't want to reinvent the wheel for the parts that actually already exist in UML and build editors from scratch and all that stuff. So that would be nice to just reuse UML for at least those parts that have a large overlap, right? The counter argument typically is, yeah, maybe that's a good idea, but if we use UML, we also get a lot of things that we actually don't need in our domain, right? So for instance, if you're interested in a subset of activity diagrams, in UML there is also sequence diagrams, class diagrams, and whatever, and you get those in when you use UML, but you don't really know how to use them for your particular domain, and you actually don't want to because what you actually wanted to create is this domain-specific modeling language. So one option, of course, and disclaimer, this is not a good option, is to decide to just don't use those parts and only define which parts of UML you use and you leave the rest away. The problem with that is if your tool still offers the users to create parts of UML that are actually not considered to be part of your domain-specific modeling language, this is not a good idea at all because this will confuse users. Some people will start to use those elements anyway. And in the end, your artifacts or your components that process those models, they won't be able to process those parts that you didn't define to be part of your domain-specific modeling language, but they just came in because they happened to be part of UML. So this is not a good idea. So the only option seems to be to just create a DSML from scratch and reinvent the wheel, right? However, if you look at the actual arguments in this discussion, whether you want to use a domain-specific modeling language or whether you want to use UML, it's actually really not about this topic. It's actually about whether you want to have a domain-specific tool or whether you use an off-the-shelf UML tool. That's the actual discussion, that's the actual topic this discussion is about. And in this discussion, obviously, a domain-specific tool is always the better choice since it can be customized and streamlined for a particular purpose. But that still doesn't mean that we can't put it on top of UML and reuse what's already there for UML if you have a UML modeling platform and not an off-the-shelf UML modeling tool. And that's exactly what Papyrus in large parts actually is. And that's how we actually use Papyrus. So for us, Papyrus is not really, it is a UML tool, but we don't use it usually as a UML tool. We use it as a platform for building domain-specific modeling languages that happen to have or reuse a certain part of UML. And actually, these diagrams, these domain-specific diagrams that I showed you before, which look very domain-specific and have custom shapes and all that, those are actually all screenshots of Papyrus that have been customized for a particular domain. And this is where how we use it most. So if you don't know Papyrus yet, just a few facts about it. So Papyrus is an open source UML platform. It's part of the, it's governed by the Eclipse Foundation, and it's based on the Eclipse modeling framework. It implements a couple of different modeling standards. So UML is one of it, but also SysML, OCL, FUML, and ELF, and further standards are implemented there. And it's supported by a rather large open source community who maintain and evolve Papyrus. It's also governed by an industry consortium who coordinate on investments done in this platform. And last but not least, and that's one of the most important aspects for us, is it enables you to build domain-specific modeling tools that happen to be based or reuse a part of existing modeling standards like UML, SysML, and so on. So how does it actually work in Papyrus to add the domain specificness of your DSML on top of UML? For this purpose, there is a dedicated concept available in UML, and this concept is called UML profiles. And the idea of UML profiles is that when you look at this pie chart over here again, when your domain-specific modeling language uses a part of that, you basically map everything that you would like to put on top you map everything that you want to reuse. You just reuse from UML, and everything that you put on top for this part, you would define a UML profile. And this specific UML profile can then contain all your domain-specific concepts. So for instance, with this UML profile, you have already covered basically your extended domain-specific modeling language and added it on top of UML. But of course, this isn't enough to create a domain-specific modeling tool. It was just basically for creating the domain-specific modeling language. So for more or less for every adaptation or extension that you did on top of UML, of course, you can make use of the UML platform for the UML part, but for everything that you would put on top, Papyrus also allows you to put tool customizations on top. So for instance, to allow more efficient editing tools for your workflows or for your methodologies, to add, for instance, custom property views and stuff like that. You can use this platform also to make these tool customizations. One thing that is also very, very helpful when creating a domain-specific modeling tool is that Papyrus itself is not only built on EMF, but also on the Eclipse platform. And that means that you can very, very easily implement workflows or methodologies in your tool by making use of the very, very powerful rich client platform that Eclipse offers. So for instance, I will show a demo later, for instance, adding custom menus, adding custom wizards and stuff like that. So that's all covered by the Eclipse rich client platform. So just to summarize why we think Papyrus is in many cases a good choice when building a domain-specific modeling tool. For the language part, Papyrus is very customizable and provides a lot of extension points so that you can, for instance, customize the graphical syntax a lot, like you've seen in the screenshots. You can customize all aspects of the tooling, such as the palette, the property views, editing behavior, and stuff like that. Since it's built on the Eclipse modeling platform, you get basically all the different capabilities of this ecosystem into your tool sets that you could then use to, for instance, provide code generators, analysis tools, and also connect it with other tools that happen to use EMF and, for instance, provide interoperability with other EMF tools. So one example here is EMF Compare is a framework for comparing two EMF models. You can, of course, use that with Papyrus too, because Papyrus is also EMF based. And last but not least, what I mentioned before is, since it's based on the rich client platform, it allows you to do all the customizations around the editing, the diagram editor as well, such as, for instance, wizards and specific views and so on. So just to give you an example, I prepared a couple of demos, and to have sort of an example that we can use throughout the different demos, I just introduce a little bit of a context, because I think that's what really is making modeling very successful. So modeling is not only about raising the abstraction to solve a problem or to describe a system, but for us, we believe that modeling also enables us to connect different sorts of people or different sorts of parts of your organization so that they can work together more efficiently. So for instance, if you look at a simple workflow here, that the first person here creates a hardware model. The second person would then specify the user workflows, how a specific hardware is going to be used, and define the user interface, for instance, on top of it. So first of all, this person would make use of this hardware model to know, for instance, exactly how big is the display and stuff like that. Once this person is finished, there is yet another person who still would like to reuse this workflow model to, for instance, run verification, simulation, and analysis methods on top of that. So it really, modeling really enables those three people to work efficiently together and to reuse their certain contributions to the overall project. And you can think of it, or that's how we often think of it, that they basically create a shared model by extending it layer by layer and add in this additional layer those aspects that are important to them. Right. Since we are interested in the graphical part here, we will now look at, for instance, an example in the domain of user workflows. So how could such a workflow language look like, just for this example? Let's say a workflow consists of tasks, and in this workflow they can be manual tasks or automatic tasks. Between those tasks we have some sort of flows, so they can run in parallel or there can be decisions whether you go one direction or the other. And each of those tasks could have a duration, a responsibility, and flows can have probabilities. So for instance, 25% of the times you go this direction, 75% of the times you go into the other direction. So now, when we want to implement something like that based on UML, of course, the first question is, what is the base language that we would like to use? Some of you might have already recognized that this language reassembles a lot with activity diagrams. So basically, in activity diagrams, we have here actions, we have here control flow and stuff like that. So we could directly start by creating an activity diagram to represent those parts that we actually want to reuse. Of course, in the next step, we will then have to identify what is not already covered by UML and would then put this on top. And what is not covered by UML is, for instance, UML doesn't know anything about, for instance, a task, whether it's automatic or manual. That's not covered in UML. Who is responsible for which task? What is the duration of a task? Or about probabilities between different control flows. And this is all what we have then to specify in this UML profile. And this looks pretty simple. So basically a UML profile consists of a number of stereotypes that define those additional types that we would like to put on top of UML. And those stereotypes can then be applied to UML models to add those additional domain-specific concepts. So for instance here, we want to extend the UML meta class action, and we want to have tasks which are either automatic tasks or manual tasks. And a task has a duration in addition, and the responsibility is covered either by a component or by an actor. And when we now apply this automatic task to an action, we can immediately not only type it, but also add this additional information on top of that. So with that, we can basically extend the UML language quite easily, and I show that in the tool in a second. Just for, of course, for not only looking at the meta model, of course, the representation of the language is very important in terms of the graphical shapes that we use. And for this, Papyrus provides the capabilities of styling diagram with CSS, so very similar to what you would do, for instance, with a web page. And that's actually super convenient because you can specify here, I hope you can read it, here a selector part which defines which elements you would like to select, and then you apply styling rules to it so that these elements in the diagram would then be styled. So let's look at that, how it looks in the tool. So what I've prepared basically is a normal UML activity diagram. You see here, this is just a normal activity diagram editor. We have all the different elements that we could add to an activity here on the right-hand side in the palette. And what we would like to do now is to specify such a profile so that we can extend UML and add our domain-specific concepts. For that, we just create a new Papyrus model or a Papyrus project. We specify that this is now supposed to be a profile, not a UML model. We define a name, let's say workflow profile, hit next. Then we select which diagram we want to initially create. Let's just create the profile diagram, load all primitive types, and hit finish. And what we get now is an empty canvas where we can start to create the profile. First of all, what we need to do is to import the meta classes that we would like to extend. So for instance here, this is the plain UML model. I can click on an element and it tells me here what the actual type of this element is. So for instance here, control flow. So what I can do now is I can import the meta class into my profile. Say control flow, I want to import a control flow, hit OK. And now I can specify a stereotype that can be applied to any control flow. When I create such a stereotype, I can just specify a name, for instance, weighted flow, to specify the probability. So let's just also create an enumeration, for instance, to define the probability. Add an enumeration literal, something like low and high. I know this is a very cheap way of specifying a probability for now, but I guess for the example it should be enough. Now we can specify a property here that we want every weighted flow to have a probability, and it should be of type probability. It should be here, yeah. Finish. And now we specify, oh, I forgot to mention the multiplicity, 0 or 1, save. And now I can specify that this stereotype can be applied to any control flow in my UML model. Hit save again. Now it asks me what I want to define this profile. This is basically a versioning mechanism so that you can manage multiple versions of your profile. I just hit OK. And as soon as I have done this, I can apply this profile to my UML model by just selecting the model here in the Model Explorer, hit plus, and select the profile that I've just created. Hit OK. Select it again. And now I can, when I select a control flow, I can apply a stereotype. And this is exactly the stereotype that I've just created. Hit OK. And as soon as I've specified this, stereotype, I can now add additional information like probability of this edge here. So just to don't bore you looking at me clicking around, I've already finished this example. So basically here you see the entire profile of this language that I just described before, and I've already applied it to this diagram here. So we can have already specified that this is an automatic task, this is a manual task, etc. And now to come to the aspect of styling, I've mentioned before that you can use CSS for that. Let's just put this here on the side and make this smaller. So this is basically just a CSS file that I've created. And in order to apply it to the model, you can just drag and drop it. And suddenly the diagram looks already a little bit more domain specific. Of course, this is just a simple example. You can use SVG shapes instead and even customize it even more to really use domain specific shapes. But this is just a simple example. And the nice aspect here is that you can directly change, for instance, this CSS file. So for instance, here we have a rule that applies to all elements that have a weighted flow stereotype applied to it with the probability high. Here it's specified currently that it's dark blue. Let's just use something different, dark cyan, and make it a little bit thicker, 8. And as soon as I refresh here, you see immediately that this edge is now rendered a little bit differently. So this is really nice to iteratively and incrementally implement your domain-specific representation of your model. All right. Of course, this is just a way of specifying the meta model and then adjusting how it is actually rendered in the diagram. This doesn't really make a complete tool yet. Things like I mentioned before, like the palette, the property views, menus, and stuff like that have to be integrated and customized as well. For all of these different aspects, there are extension points in Papyrus that allow you to create a custom diagram type where these things are then automatically included so that you, for instance, would not have to apply manually a profile and do all that the steps that I just showed you, but this will then be automatically done. And then you can use Eclipse to even further customize your whole tool so that it looks quite, or that it reflects the needs of your specific domain experts. And I've prepared a little demo for that as well. So just to show you this picture again, I've prepared a small example tool which takes a hardware model, then generates the initial empty model that already contains the hardware model for creating workflows, so that this user can directly make use of that model, then just create the workflows, and then that another person can use that workflow to make analysis, for instance, about it. So how that looks like is, here a second tool where I've already created an empty Java project. Let's assume the second person uses Java to implement the user interface. And here in this coffee model, that's the one that I've opened here, that's a plain EMF model. The person before has already specified which hardware components are included in a specific coffee maker, for instance. And this guy specified that there is a control unit, a brewing unit, a water tank, dip tray, and so on and so forth. So what this user can now simply do, she can click on the element here and initialize a new workflow diagram. And that's exactly what I meant before with making use of the Eclipse rich client platform by introducing additional wizards. So as soon as you click here, you see that an empty workflow file is already created, which has already applied all the profiles that we defined before. And you can also see here that the palettes have been customized so that only the elements that we actually want to include in the domain-specific modeling language are shown. And I can already create, for instance, here an automatic task or a manual task. As soon as I click on one, you see here that we have a customized property view as well. So only the aspects that are important for this language are shown. So for instance, that's the name, the duration, visibility, and the responsible component. And when I click here that I want to specify the responsible component, I see exactly the elements that have been specified in this other model before already. So that has been already imported. So this person can click here and save. Another thing that is already included here is, since we also want to make use of this model to specify, for instance, the user interface, we've integrated a simple code generator. So whenever you create a new task, you hit save, you see that a Java class is being created. And as soon as you want to go into this Java class, we would like to integrate the model and the code as much as possible. So it's pretty easy to just, for instance, add here a menu item to navigate from a model element to a code, so that we automatically jump to the code that is, for instance, being generated for a specific element. And here in this code, everything is already working fine because we set up the project correctly and stuff like that, all automatically, to make it as efficient as possible for the domain expert to work with. And we can then, for instance, here navigate to the component that the user has set, or query the duration and start implementing something. So that's what I mean with trying to integrate as close as possible to the workflow of the dedicated stakeholders in the domain-specific application of creating a specific task. So for instance here, creating the workflow of a coffee maker, and try not to put a generic modeling editor in place, an off-the-shelf modeling editor, but really find out how you can help this expert best and integrate into their workflow to make their life easier. So that's, I think, a very important part. So one other cool thing is I just switched back to a project that I've already prepared, which has more elements in it already. One really nice thing is that you can integrate with any other EMF technology, since Papyrus is EMF based. So for instance, you can also very easily integrate with Xtext. So for instance, here I have an Xtext model that now, for instance, this third guy could use to analyze the workflow. And this Xtext model can be set up to reference the workflow that this other person just created. So for instance, here we can make assertions that this action or this task is being performed before this task. And of course, we have here all the nice things that Xtext provides us. So for instance, here we list all the elements that have been created in this workflow automatically. Same is also true, for instance, when I introduce here, now when I save that, go back to brew here and rename that to brew1. Save that, you see immediately that the other model, the textual model, get invalid because the name brew does not exist anymore, and you can even provide quick fixes so that you can automatically fix the issues that you've seen here. Of course, you can, since it's an EMF, plain EMF model, just undo that, save, save. Now all the errors are gone again. Since the Papyrus model is an EMF model, you can also apply, make use of the EMF API to analyze a model. So for instance, let's say this third guy here with the classes would like to run verifications or simulations and would like to find out what is the probability of each trace through that workflow. So therefore, you can easily implement components that analyze the workflow. We've integrated here now this button called Perform Workflow Analysis, and when you click on it, we run basically a tool that iterates through the model, computes the different combined probabilities so that someone could directly analyze, for instance, what is the probability that we go from push, check water, okay, until the end, and then, for instance, find out that this specific path is being performed and executed in 37.5% of all times. So this is really a nice way of showing that you can actually produce value out of your models by just writing components that analyze those, or by generating code, and that's all really nicely covered with Papyrus since it's EMF based. Right. So what does that mean in conclusion? So we are not saying that that you should use UML for all your projects and you should use Papyrus for all your projects. Our main message is that domain specificity is a key factor for success in modeling, and that means that streamlining and customizing your tool as much as possible is very, very important. And that means both making it very custom and removing everything from the tool that is not being used by your domain experts. That's just as important. However, even if we do a very domain-specific tool, that doesn't mean that we cannot make use of existing UML tools and save a lot of time by reusing what's already there. For that, when we want to do that, we need a UML platform, and Papyrus is a very good choice if you would like to use Papyrus and extend it, or use UML and extend it, then Papyrus is a very good choice. There is a couple of advantages if you use UML as a base language in certain areas, and this is, first of all, for many companies or organizations, it's kind of important to rely on standards, because they need to, for instance, fulfill some sort of interfaces when then generating documentation or safety analysis and so on. It's good to reuse standards. Another good advantage of it is that if you use UML as a base language, the interoperability is increased a lot. So, for instance, if you imagine two groups of your organization start building their own modeling tool, and both create the domain-specific modeling language, it's very hard to integrate that at some point when you find out, this part of the organization could reuse certain parts of this other model that has been created. That's very hard if it's plain domain-specific modeling. If both happen to use UML at some point, there is a common language that they speak, and you can link those models underneath very easily. So that's another good example, and a good advantage. And finally, it's very good to avoid reinventing the wheel over and over again. So if there is already a diagram type in UML that covers like 60 or 70% of your requirements, why not just reuse it and only add those additional things on top? So in conclusion, all depends really on the characteristics of your domain-specific modeling language. If there is a high overlap, it's certainly worth looking into reusing UML. If there is no or a very, very low overlap, it might be still better to just create a domain-specific modeling language from scratch. So that's what I meant before. I'm not saying use Papyrus or UML for every single language that you can think of, but really take it into consideration. It might save you a lot of time if you reuse Papyrus, if it makes sense. So that's basically all what I wanted to say. If you use UML and you use Papyrus, then make sure you customize your tool accordingly and let us know if you have any issues with it. Thanks a lot for your attention, and I'm happy to take any questions. Other questions so far? Right. So the question was which code generator would we recommend? So in my experience, most of the code generators are domain specific. So you have to purposefully write them for a particular use case. And for writing such domain specific code generators, we use mostly extend. We mostly use it in a way that we write as much as possible in plain Java, but then the actual templates to generate code, therefore we use extend, because there you have nice features like these template expressions where you can very easily and conveniently write code and only change the dynamic parts. That's what we do. But I don't believe in, or I don't usually believe in generic code generators, so that's usually not very helpful. Welcome. Any other question? Nope. If there is no question, then thanks a lot again for your attention. And if a question arises later on today or tomorrow, just find us at our EclipseSource booth right over there, or feel free to just drop me an email. Thanks a lot and enjoy the rest of the conference.